This is geometry practice quiz for our logarithms unit. Let's jump in. So in number one, we're going to solve for x. I see a right triangle. Whenever we're trying to solve for side lengths with a right triangle, we're almost always going to be using a squared plus b squared is equal to c squared. So in this case, that's called the Pythagorean theorem. In this case, we're going to have x squared plus the other leg, and be careful of your leg. The leg should be the not the longest one. The hypotenuse is always the longest one, so it's going to be 12 squared is equal to c squared. No, not c squared. 13. 13 is your hypotenuse squared, Mr. Sindel. Jeez. Go ahead and expand these out. So this is going to be 144. We still have that x squared over here. That's going to be equal to 169. Hopefully you know your squares by now. I need to subtract 144 from both sides, so minus 144, minus 144. When we do that, the 144 cancels out. I'm left with x squared on the left-hand side of the equation. On the right-hand side, the hundreds are gone. That's going to be 25. Oh, that came out really nice. So I have to square root both sides to get x by itself. Square at the left, square at the right. And x is equal to 5. Final answer. Box it. In terms of scoring yourself, you can practice if you want, but for now, I would just ignore it. Focus on learning the math. Number 2. Again, we're left with a right triangle, and we're trying to find side lengths, so I'm definitely going to be using our a squared plus b squared is equal to c squared. Bad handwriting there, but it's okay. Plugging in, again, legs can be a or b, doesn't matter where they go. 4, sure, squared plus, okay, this is going to be the quantity of 5 square root of 2 quantity squared is equal to that x squared in this case. All right, well, this 4 squared is easy, that's 16, but where I'm hoping, not plus, not equals, it's a plus. I'm hoping this probably tripped a few people up. This is how you do this problem. Whenever I have 5 square root of 2, if I have a non-square root and a square root and it's to some power, you distribute the power to both of these terms. So it's really going to be 5 squared times the square root of 2 squared. And the square root and square cancel each other out. This is going to be 25 times 2, and that's just going to be 50. So over here we're going to have 50 is equal to x squared. Add these two together, I get 76 is equal to x squared. And finally, I'm going to square root the right side, square root the left side, and I get x is equal to the square root of 76. And it says simplify all square roots. So I need to see if there are any perfect squares that come out of this. And I see one. So again, I'm looking for numbers like 4, 16, 9, 25, things like that. Those are perfect squares. So look for your factor tree. And one of them I can see is 4. And you might say, Mr. Sindel, how do you know that? Well, I see that this number is really close to 80, which is divisible by 4. And if I just subtract 4 from 80, it still should be divisible by 4. I only subtracted 4. So one of the factors is the square root of 4. The other is square root. And again, you can do this longhand if you want. It's going to be 19. You can check 4 times 19 out on the side to make sure that I'm right, but I think that's right, 76. And then 19 is a prime number, so I can't do anything. The square root of 4 does turn into 2. So your final answer should have been 2 square root of 19. If you only put the square root of 76, yeah, I probably would give you most of the points. I'm not going to give you all, and that's what simplify square roots means. You know how to boil it down into this. Number 3 was rough. It had a lot of numbers, a lot of big numbers. So I'm still using Pythagorean theorem. I'm still using the a squared plus b squared is equal to c squared. And again, I'm giving you the legs. I kind of gave you the same problem as number 2, but bigger, harder. So I can choose a and b to be whatever I want. I can say a is 140 squared plus b is 50 square root of 5 quantity squared, and that's equal to not c squared, it's going to be x squared now. X squared, solve for x. And I do say you should use a calculator, but I don't think you need to. I'd like to try this one without using a calculator. 14 squared, and then I'll do 10 squared after that. 14 squared is 196. And then 2 zeros, because 10 squared, plus, all right, 5, it's 50 squared. Mr. Sin, oh my gosh, 50 squared. Is, well, 5 squared is 25, and then 10 squared is 1,000, and then square root of 5 squared is just square root of 5, so multiply by 5 is equal to x squared. And finally, 5 times 25 is 125. Add the 2 zeros there. We still have 196. 100 is equal to x squared. Go ahead and add these really quickly. 5 brings it to 11, which brings that to 2, which brings that to 3 with the 2 zeros. We've got 32100 is equal to x squared. Finally, we square root the left, square root the right, and now I need to figure out what that is, because I did say simplify all square roots, just like I did in number 2. So let's do our factor tree method for 300, or I guess 32,100, or 32100 if you will. One of the factors is 100, so the square root of 100 goes into that. That means the other one is the square root of 321. And that simplifies really nicely to just 10. Square root of 321, does that have any perfect squares that go into it? And I don't think there are, so I think that's as far as I can go. That means our final answer is going to be x is equal to 10 root 321. And we get our final answer. Again, I should probably check that on my calculator really quickly. So let me move that to the right and pull up my calculator. So first of all, did I do 140 squared right? I don't trust myself. Yay. Did I add that with, let's do 50 square root of 5 squared. They got 32,100, just like I did. And now the next question is into 321, and this is probably just a question I'll Google. Factors of 321, just to make sure I'm doing this right. 1, 3, 107, and 321, which meant just 3 and 107. 3 and 107. Wow, that was it. And those are both prime numbers, so you can not go any further. 3 and 107. You can't go any further than that. So I can add that for the notes. And yeah, that means I got the right answer. Woohoo! Number 4. I know the question is everyone is asking, are you going to put one of these on the actual quiz? And the answer is yes. Yes, I will. So make sure you're comfortable using a calculator and knowing how to simplify your square roots. Number 4. Yeah, special right triangles. 4, 5, 6, and 7. I have 4 of these problems. So the first thing that I notice is this is a 30, 60, 90 triangle. Why? Because those are the interior angles of our triangle. So our little trick is you never go over the sharp corner. You can think like you'll cut yourself. So you have to go through this small leg. So the general idea here is move to the short leg and then move to the hypotenuse. And we know that if we go from the long leg to the short leg, we divide by the square root of 3. So what do we do here? What's 6 square root of 3 divided by square root of 3? Oh, well, those cancel out, and you're just left with 6. That means that the short leg here is 6. And then how do we move from the short leg to the hypotenuse? You multiply by 2, and 6 times 2 is 12. So x is, I should probably just say, have an x here. X is equal to 12, and that's our final answer. And that's as much work as you need to show. I would like you to show what operations you're using, so I can follow what you're doing, especially if you have the wrong operation here. I can really see what's going on. This is a different type of triangle. This is a 45, 45, 90 triangle. Again, those are the interior angles. You might say, you left one off. Well, there are 180 degrees in a triangle, so you can add these up and somehow figure out that that is 45 degrees here. And the trick with 45, 45, 90s, to move from the hypotenuse to the leg, you divide by the square root of 2. So I have 4 square root of 2, and I divide by the square root of 2, and hey, those 2 cancel out, and I'm left with 4, which means our answer, x, is just 4. I'd give you some hopefully easy ones in 4 and 5, and then I made the next 2 harder. Moving on to number 6. So solve for x again. And again, I have a 45, 45, 90, so the same trick applies. I'm going to go from here to here. Oh no, I want to go the other way. So if I go this way, instead of dividing by square root of 2 like in number 5, now I'm going to multiply by the square root of 2. So what is 8 square root of 5 times the square root of 2? The cool thing with multiplication is you only multiply the things that are the same. You multiply radicals with radicals and all the non-radicals with the non-radicals. So 8 can't multiply with anything, so 8 is left over. I can multiply the 5 and the 2, and this is just the square root of 10, and that is our final answer. Number 7, a 30, 60, 90, and I'm moving the same direction as in number 4. Wow, too easy. Mr. Sandel is so nice. To move from here to here, you're going to divide by the square root of 3, and then to move from here to here, you're going to multiply by 2. So those are our operations. So what is 7 divided by square root of 3? You might think, Mr. Sandel, normally you gave us like problems like 12 divided by the square root of 3. I'm making up a number. What if this was a 12 instead of a 7? It would have been a much easier problem, right, Mr. Sindel? Because we know the shortcut. The shortcut is this turns into 4 square root of 3. And then you can go from there. Well, the thing is, you don't always have to use a shortcut. In this case, this is an area where you say, oh, this is just 7 divided by square root of 3. And you have to do it the long way. Mwahaha. And what is the long way? Well, you'll remind yourself. To get rid of that square root of 3, what you're really doing was you're multiplying the top and bottom here by square root of 3 over the square root of 3. When you do that, then you get 7 square root of 3. I meant to write a 7 up there. A 7 square root of 3 in the numerator, the top. And in the denominator, we have the square root of 9, which is nice because that is just 3. So our new fraction is 7 root 3 in the numerator, 3 in the denominator. All right, and we don't need to multiply by 2. We just needed x. So we don't multiply by 2. That would have found this length up here. We only need the short leg, and the short leg is 7 root 3 over 3. If you left your answer with a square root in the denominator, it's not rationalized. So you typically in math, in my class, definitely never have a rational in the denominator, or an irrational in the denominator. There's the word I'm looking for. Don't put a square root down there. Number 8, some basic trig functions. So I'm going to write out our SOHCAHTOA so I can remember what I'm doing here. All right, I'm doing cosine of b. So I'm doing this angle of reference, and cosine is adjacent over hypotenuse. So if I'm looking at b, then my adjacent, my next door neighbor is my 3, and the hypotenuse is 5. Hypotenuse is always the one opposite of that 90-degree angle, right? And done, right? Now we're on to b, tangent. So that's going to be opposite over adjacent. And it's tangent of A. It's tangent of this angle of reference in the top. Well, if that's my angle that I'm looking at, my adjacent is really my 4. That's the angle, or the leg that is closest to it. So it's going to be opposite first, the other one, 3, and then divide by 4. 3 divided by 4. If you took the reciprocal of this, that would have been tangent of B. Moving on to number 9. So this one you are definitely going to need a calculator. So let's do the math first and then use a calculator at the very end. And I said round to 3 decimal places. So we want to solve for x, and that's a 39-degree angle. So I'm going to use a trig function. I get to choose which one I want to use. Well, what's a trig function? And if this is my angle of reference, uses the next door neighbor leg, also known as the adjacent, and the opposite leg, also known as the opposite. So O and A. Oh yeah, that's tangent. So I'm going to say tangent of 39 degrees is equal to that fraction opposite over adjacent is equal to the fraction x over a, and a in this case is 3. Well, if I want to solve for x, I multiply both sides by 3, multiply by 3 on the right side, multiply by 3 on the left side, and the right side, those 3's cancel out, and my final answer is that thing. And now I need a calculator. And when I do a calculation, I'm now going to approximate this. It's not a strictly equal to because I'm rounding here. So calculator, go. We don't have factors of 321 anymore. Let's come back here and say, what is, and make sure that this is in degrees. Right now when we're in degrees, right now when we're in radians, so just in case you accidentally click the button, you will get a different answer. What is 3 times tangent of 39? And the answer is 2.429. And again, this number, this number right here is a 3. It's not highlighted on my screen, but maybe it is for yours. So it does not round up. It just says 0.429. 2.429. So, 2.429. And again, I should be boxing my work whenever I have work up here. If you get right to the answer, you don't really need to box it. Last 2 problems. Use the law of sines to solve for theta. So the law of sines basically says you can do, and it doesn't matter if you have the angle or the leg on top. I'm just going to do the leg randomly. I'm going to say 9, sure, over sine of the angle that is opposite to it. So opposite angle is, okay, 50. On the other side is 50. And that's going to be equal to probably the other length over here. And 7 is indeed opposite of the theta. So I'm going to say 7 divided by the angle that is opposite to it, sine of that theta. Sine of theta. And then I have an equation using the law of sines, and now I'm just going to solve. It sounds easy, but I think the first thing that I'm going to do is I'm going to flip both sides. I'm going to take the reciprocal of both sides. You're allowed to do that as long as you don't accidentally divide by 0, and we're not in danger of doing that. So now I have the equation sine of 50, all of this divided by 9 is equal to sine of theta I'll divide by 7. That is nice because when your variable, theta in this case, is in the denominator, that's never nice. The variables in the numerator is a lot easier because now we can just multiply both sides by 7, and we're really close to getting theta by itself. The only thing that we need to do is we need to, I'm going to move this stuff a little bit to the right here. We need to undo sine. If I undo sine, because right now I have the equation, I'm running out of room here, of course. I have the equation sine of theta is equal to 7 sine of 50, all of that divided by 9. I need to undo sine. The way that you do that is you take arc sine. Arc sine is sine to the -1, or you can actually spell out ARC SIN. If I take arc sine of the left, I must take arc sine of the right, both sides, and arc sine and sine cancel each other out, and we get theta by itself. Theta is equal to, and I have to punch all of this into the calculator and round to 3 decimal places. So I'm not going to box that because it does want me to round here. Let's, I should probably make this come over here. All right, calculator, go. We've got arc sine ARC SIN, arc sine of, and then all of that fraction. So I'm going to set up my fraction by hitting my dividing by key, and it's going to be 7 sine of 50, and then in the denominator we have 9. And rounding to 3 decimal places, 36.571. Again, the 0 gets rounded up because it's followed by 5. So 36.571. 36.571. 36.571. Me being the mathematician, I want to be exact. That's not really an equal to sign. So let's go ahead and delete that. And we're really approximating here. We rounded it. It is exactly equal to this down here, but now that we've rounded it, it is approximately equal to. So the wavy equal to sign is approximately. And the hardest problem of all, number 11, using the law of cosines to solve for theta. So the general formula of law of cosines is probably something that we should start with. I'm going to start down here in the bottom left. Hopefully we won't run, we're definitely going to run out of room, but hopefully we'll try to conserve our space a little bit better. The general idea is that this, this side, that's the word I'm looking for, the side that is opposite to theta is going to be the one that you start with, and it's going to be squared. And it's going to be equal to, it's basically Pythagorean theorem, guys. Like, look at this. It's c squared is equal to a squared plus b squared. That's essentially what a law of cosines is. It's going to be 7 squared plus 9 squared, but there's a problem. The problem is that this is not a right angle, so you have to modify Pythagorean theorem by just subtracting cosine, subtracting a, it's 2, isn't it? 2 times a times b times cosine of theta. And that will correct for our Pythagorean theorem so that it accounts for that 90-degree angle. So if we do that, it's going to be 2 times a and b. Again, we're 7 and 9. A and b are always the sides, the adjacent the adjacent sides of the triangle. So it's 2 times 7 times 9 times cosine of theta. And we've set up the equation. I mean, if you get that far, you definitely get some points. Now it's the hard part of how do we throw everything to the other side of the equal to sign until we get theta by itself. Well, the first thing that I can do is I can let's say that this is going to be not 6, but 36. 36. Conserve space, Mr. Snell. It's going to hit us later. 36 is equal to 49 plus 81 minus, can I do this in my head? 7 times 9 is 63, so 126 cosine of theta. And then I'm going to add these two together and subtract them at the same time. So if I add them together, the 9 and 1 become 10. So carry that becomes a 5 instead of a 4. 5 and 8 is 13. So this is 130. So I'm going to subtract 130, which is those two, and subtract 130 for both sides. And when I do that, I now get negative 126 cosine of theta is equal to this thing, which is some negative number. Negative 94, I think. 94. I hope I'm right. If I'm wrong, please comment on it. You'll get extra credit. I love being wrong. Divide by negative 126. Divide both sides by negative 126. Divide the left-hand side by negative 126. And negative divide by negative, those are gone. And then I have this gross fraction, which I will just leave as 94 divided by 126. Yes, you can divide the top and bottom by 2, but it doesn't get it that much nicer. Right now we're left with this 94 over 126 is equal to cosine of theta. And from here it might seem pretty straightforward. All we need to do is undo cosine. So what do we do to both sides? We take the arc cosine, this cosine to the -1 of the right, this cosine to the -1 of the left, and we're done because the arc, cosine, and cosine cancel each other out. They are inverse operations, and I get theta is equal to, just type that into the calculator, Mr. Sindel, and hopefully this will be nice for us. Let's go. We got arc cosine of, it's going to be a fraction, so let's set that up. It's going to be 94 divided by 126. And again, round to 3 decimal places. So it's going to be 41.752. 41.752. 41.752, and Mr. Sindel, he's being slightly pedantic. I'm not using an equal to sign here. I'm using the approximate sign because we have now rounded. And does that make sense? So this leg, or this, I keep saying leg, this side is smaller, which means this should be a smaller angle. If this was an equilateral triangle where it was like perfect, where all of these sides were the same, it would be 60, 60, 60, 60. And because this one is smaller, this angle should be less than 60, and it is less than 60. So in my mind, that does make sense. I might have made a miscalculation in here. It doesn't happen very often because I've made lots of mistakes and learned from them, but I'm still willing to make those mistakes and still learn from them. Whew, that was a long video, guys. Again, if there are any mistakes that I made in the key, please let me know. And if you have questions about anything, maybe what's going to be on the real quiz, grading, how do you give points, stuff like that, just leave those as comments in Google Classroom. I'll answer them. With that, guys, I will see you guys later.